All right, so we spent some time last time talking about straight line motion, and we did a lot of problems that involved graphs and how to interpret the graph of position, how to interpret the graph of velocity. What we're going to do today is talk about how to interpret those same things, but without having the graph in front of us. And this is going to be a skill that will be assessed on the AP exam quite a bit. So I've got a problem here. I've got a position equation that I was given. The position is given in meters at time t seconds. The equation you can see, and then I'm asked this following questions. When is the particle moving to the left, moving to the right, at rest, accelerating to the right, accelerating to the left, and not accelerating, and then speeding up and slowing down. So we're going to address each of these. So the first part A, moving to the left, moving to the right, and at rest. Those all have to do with velocity. So moving to the left is when the velocity is less than 0. Moving right is when it's greater than 0. And not moving, or at rest, is when the velocity equals 0. Now, so what I would like to know is when the velocity is what sign, S-I-G-N. So, first thing I would need to do to answer this question is find the velocity. And of course, velocity is the derivative of position. And the derivative of that equation would be this. 3t squared minus 18t plus 15 plus 0. Now, I want to know where this thing is positive, negative, and equal to 0. Now, if I were looking at this as a graph, it'd be an upward-facing parabola, right? So it'd be something like this if it crossed the x-axis twice. So there'd be a spot where it's above the x-axis, below the x-axis, and at the x-axis. But I don't have access to a graph here, and in some problems where you don't have access to a calculator, the velocity equation may not be an easy thing to visualize the graph of. So when we need to know when a function is positive or negative, we're going to make something called a sign chart, or a sign line. Now, a sign chart is essentially a number line, and it's a number line that's going to let us tell when a function is positive or negative. Now, the function we're testing positivity and negativity for right now is velocity. So every time you're using a sign line, you should draw a number line and label it with the function that you're testing. Now, here are the steps for making a sign chart. First of all, we need to know where the function could change sign. Basically, that's where it crosses the x-axis or hits the x-axis, or when it's undefined, like there's a discontinuity, it could change sign across that. So the first thing in making a sign chart we're going to do is we're going to find where, in this case, its velocity is equal to 0 or undefined. By the way, if you remember, we had a name for those points. We talked about that last time. A place where velocity is 0, where a derivative is equal to 0 or is undefined. That's called a critical point. Sometimes called critical values. So if I look at this velocity equation that I have up here, that's a polynomial, so it's never going to be undefined. So basically what we want to do with that is take it and set it equal to 0. Now I see that I can factor out a 3 here. And then I'll factor, that'd be t minus 6 and t minus 1, I believe. So, sorry, t minus 5 and t minus 1. So my two values will be t equals 5 and t equals 1. So what I'm going to do on my sign line is I'm going to take those two numbers and place them on my sign line. Those are the places where the graph of the velocity would cross the x-axis. So now I need to figure out where the graph is above and below. So I'm going to take numbers, I'm going to test numbers in each interval to determine their signs. So an example of that, in the interval where it's less than 1, a number in that interval is 0. If I take 0 and plug it into the velocity equation, I would get 15. That's a positive number. So that means all the numbers in that interval are going to be positive. It's 0 at 1. If I plugged in a number in between 1 and 5, say 2, Let's see, that would be 12 minus 36 plus 15. That's definitely a negative number. So everything in that interval is negative. It's 0 at 5. And then number bigger than 5 would also be a positive number. By the way, you knew the thing I drew at the beginning where I had the little parabola for this graph? It's basically like that. So you can see the x-intercepts are at 1 and 5. It's above the x-axis when it's less than 1 and above when it's after 5. And it's below between 1 and 5. But just in case I had a equation that was hard to visualize the graph, I want to be able to do this sign chart. So what this basically means is my velocity is positive, which means it's moving to the right. When t is less than 1, so negative infinity to 1. Now you probably would have a problem that says t has to be greater than 0, so it would be from 0 to 1 in that case. And then from 5 onward. And it's moving left when t is between 1 and 5. It's at rest when t is 1 and when t is 5. Now, that's a sign chart, basically. You find where the function you're trying to determine its sign, its positive or negative, sorry, is equal to 0 undefined. You put them on a number line, you test the intervals, and you label the signs. So for part B, it's asking where it's accelerating to the right, accelerating to the left, and not accelerating. So we're actually going to follow the exact same process for B, making a sign line, but this time we're interested in where the acceleration is positive, the acceleration is negative, and where the acceleration is 0. So I find the derivative of velocity because that's acceleration. That's never undefined. So I find where it equals 0, and that happens at t equals 3. I draw a sign line. I label it. On the sign line, I put my critical points, although they're not called critical points because we're dealing with a second derivative. And then I plug in numbers from each of the intervals. So when I plug in 0, I get negative 18, so all these things are negative. When I plug in 4, I get something that's positive, so all these are positive. It's 0 at 3. So then it's accelerating to the right when the time is bigger than 3. It's accelerating to the left when the time is less than 3. And there's no acceleration when time equals 3. Now, with those two pieces of information, we can actually answer part C. C is asking for speeding up and slowing down, and remember, speeding up, acceleration and velocity have the same sign. Slowing down, acceleration and velocity have opposite signs. So what I like to do is I like to make sort of a super line like this. On the top of it, I'm going to put velocity. On the bottom of it, I'm going to put acceleration. Like this. So you see the white sign line I made, the one for velocity? It had zeros at 1 and 5. And it was positive, negative, positive. And my acceleration, the green line, had a 0 at 3, a critical point at 3, or not a critical point, but you know what I mean. And it was negative and positive. So any of the intervals that you see where the signs are the same, it's speeding up. Any of the intervals you see if the signs are opposite, it's slowing down. So if I wanted to answer this question, I want to write speeding up and slowing down. I'm going to write a t as an element of. And now I'm just going to read this number line from left to right. So when it's less than 1, velocity is positive, acceleration is negative, so it's slowing down. From 1 to 3, they're both negative, so it's speeding up. From 3 to 5, opposite signs. So it's slowing down. And bigger than 5, they're both positive, so it's speeding up. So when you're trying to figure out whether something's moving to the left, moving to the right, accelerating to the left, accelerating to the right, or speeding up and slowing down, making these sign charts and making appropriate comparisons is the way to go.